Hi guys, my name is Minhajuddin Ansari and you're watching the 18th tutorial on C programming, and today I'm going to talk about recursion. So you already learned in our previous tutorial that a function can call on another function. So when a function calls on itself, this is called recursion. And I'm going to try to find the factorial of a number using recursion. So those of you who don't know what a factorial is simply the product of a number with all the numbers below it up to 1. For example, the factorial of 5 would be 5 times 4 times 3 times 2 times 1, which would be 120. The factorial of 4 would be 4 times 3 times 2 times 1, which would be 24. And the factorial of 3 would be 3 times 2 times 1, which would be 6, and so on. So I'm going to find the factorial of any number using a recursive function, a function that calls itself. So first I'm going to write the structure of the recursive function. I'm going to write the return type as integer, and I'm going to write the name as fact, and inside the parameter list, I'm going to include a integer variable a. So now inside the body of my fact function, I'm going to write a base case. And the base case simply tells the program when the recursion should stop. So I'm going to explain to you in a moment. So let me just write my base case if, and it's going to be a condition. So if a is equal to 1, then I want this function to return the value 1. And at the bottom right here, I'm going to write my integer variable result, and it will store a multiplied by factorial a minus 1. So you can see right here, I'm using the factorial function. So this is recursion is happening right here. And I'm going to simply, let me just add my semicolon right here. Let me move this back. And in the end, I'm simply going to return the value of the integer variable result. So now in my main program, I'm going to define an integer variable a is equal to 5, and I'm going to define another integer variable store, which will store the value of the factorial, and I'm going to call my fact function, and I'm going to pass the value of the variable a as argument. So now, and in the end, let me just print it. Why not? So I'm going to print it using the printf statement, the integer variable store. So when I run the program, I'm going to get 120 in my output screen. This because this is the factorial of 5. Similarly, the factorial of 4 would be 24. So when I run the program, I'm going to get 24 in my output screen. Similarly, the factorial of 3 would be 6. And again, when I run the program, 6 is going to be displayed in the output screen. So how is this factorial function actually working? And for that, I'll have to open Paint. So right here, I'm going to rewrite my factorial function, int fact, and its parameter is inside the parameter list. It has a single integer variable, and I'm going to write the base case. If a is equal to 1, then return 1. I'm simply writing the code which I wrote in the Visual Studio Editor. Else I'm going to do integer result. This should store a multiplied by fact a minus 1, recursion right here, and return the result. So suppose, okay, I'm going to write with my orange color, I'm going to write with a blue color. So suppose I passed the factorial, for example, in my main function, I call the factorial function from my main function. So this is my main right here. And I'm calling the factorial function, and for example, I send it the argument 3. So I'm sending 3 as input to the factorial function. So what will happen is that the factorial function will be called and 3 would appear right here. And since 3 is not equal to 1, so the if condition is not satisfied, so this statement will run right here. So result is equal to 3 times factorial 3 minus 1, which is 2. So now the factorial function is being called again, but this time with the argument 2. So again, I'm going to change my color, and I'm going to write fact2, And since 2 is not equal to 1, so this if statement will not execute. And inside the fact2 function, the result would be 2 times fact a minus 1. In this case, a is equal to 2. So 2 minus 1, which would be 1. And again, factorial is being called with the argument 1. So I'm going to change my color. Let me write this dark brown color. This looks good. So now I'm going to receive 1 as input in my factorial function because it's being called right here. And now since 1 is equal to 1, since a is equal to 1 in this case, because a is 1, and since it is equal to 1, so this function, this factorial function right here, this will simply return 1 to the calling function. So since this function, this factorial 2, this function was the calling function for factorial 1, so it would return the value 1 right here. So this would be replaced by 1. And now 2 times 1 is equal to 2. And let me change my color again. And return result, the final statement returns the result. So in this case, it would return the result to the calling function. And it will return 2 to the calling function. And the calling function is actually the factorial function 3. And because it was being called from here, factorial 2 was being called from here when the input was 3. So that means it will be returned right here. Factorial 2 would evaluate 2. 2 times 1 is equal to 2. The value of the result would be returned right here. And in the end, 3 multiplied by 2 would be 6. Let me change my color again. And the 6 would be returned back to the main program, because the main program called factorial 3. So it would be returned right here, 6. And that is why we get a 6 when we print the value of the integer variable store. I think it's store, right? Yeah, store. And I've written result right here. Doesn't matter, just change the name. So now what is the purpose of the base case? The base case simply identifies or simply specifies the end of the recursion. Because suppose I didn't write the base case right here, I removed this line right here. So what would happen is that when result is 2 times factorial 1, so when factorial 1 is called, then since there is no condition, so instead of returning 1, it would again store in the result 1 times factorial 0. Because there's no base case, there's no condition to stop the recursion. And then factorial 0 would again be called, factorial function will be called with the input 0. And then since there is no if condition, then result would store 0 times factorial 0 minus 1, which is minus 1. Again, the factorial function will be called and with the input minus 1 this time. So again, result would be minus 1 times factorial minus 2. And again, factorial with input minus 2 will be called. So, you can see that this will continue on infinitely. The recursion would not stop, because then this would be result is equal to minus 2 times factorial minus 3, and this would continue on to minus 4, minus 5, minus 6, minus 7, minus 8, and this would continue on infinitely and until your program crashes, because this will consume the entire memory in your stack. And so, that is why you have to add the base case. You have to add a condition when the recursion should stop. So this is all it about recursion. If you have any questions, please ask them in the comment section. I highly recommend you practice recursion because this is a very important concept. So practice it in your free time, and thanks for watching this video.